everyone, good evening. Welcome to another YouTube video on mathematics. These are the topics we're going to be treating. We may not treat all of them in this video, but we will treat some. So let's start with the very first one, which is fractions and decimals. So what exactly is a fraction? A fraction is a number written in the form of numerator over denominator. So this Word document may not really explain it much, so let me write it out here. Okay, let me use a different color actually. So yeah, numerator, just going to summarize it like that. Numerator denominator. So this is the format you would see for fractions. So you can have something like 2 over 4 or 3 over 4 or 5 over 4. Basically anything that is like numerator over denominator. Usually the numerator is smaller than the denominator, like we see here in 3 being less than 4. Let me actually clean this. So we have like 2 over 4, this is a fraction. 3 over 4, this is also a fraction. Or 5 over 4, these are all fractions. Now we have different types of fractions. We have improper fractions, proper fractions, and even equivalent fractions. So this is what we call a proper fraction. A proper fraction is any fraction that the numerator, which is this one up here, is less than the denominator, which is this one down here. So this is what we call a proper fraction. So let me just write it out. Proper fraction. Let me just do something like this. Fraction. Okay. Forgive my handwriting, but I mean, at least you get it. So this is a proper fraction. Now we also have something we call improper fraction, and this is an improper fraction. Sorry. Improper fraction. And its own concept is the reverse of this. So the numerator is now greater than the denominator. So 5 is bigger than 4, so this is an improper fraction. You can just imagine it as having something too heavy, or like a big guy or a fat guy on top of a child. So that's how you can, that's one idea you can use to memorize improper fractions or understand what it's all about. Then we also have something else as well, mixed fractions. So let's see this, let's take this improper fraction, for example, 5 over 4. 5 over 4 can also be written as one whole number, 1 over 4. And these type of fractions are called mixed fractions. Mixed fractions. There we go. Okay. Now, why is it called a mixed fraction? Because you have a whole number and you have a fraction. So the whole number is this one here, and the fraction is this 1 over 4. So assuming we want to take this mixed fraction back to an improper fraction, it's actually pretty simple. Let me use another color. We do 4 times 1, so 4 times 1, and that will give you what? That will give you 4, right? 4. Then this one over here, we add it to it, and that will give you what? 5. So that will give you 5 all over the 4. The 4, which is this 4 over here. So 4 times 1, 4, plus 1, 5. So 5 over 4. Now what if we wanted to take this to this? That's also very simple. 4 in 5 is what? 1. What's the remainder? 1. So 4 in 5, 4 or 5 divided by 4, or 4 in 5 is 1. And the remainder from it is 1 as well. So all over 4. So that's how we get mixed fractions and vice versa. Now the other type of fraction is the equivalent fraction. Equivalent. Equivalent fractions. Now these fractions are just fractions that equate to each other, that are equal to each other, or can be simplified to each other. Now 2 over 4, 2 over 4 can also be written as 1 over 2. And why is that? It's very simple actually, because we can easily say 2 into 1 and 2 in 4, 2. And if you want to get back to 2 over 4, you can also say 1 times 2 and 2 times 2, and that will still give us back the 2 over 4. This one was basically 2 divided by 2 and 4 divided by 2. So basically, equivalent fractions, they are equal to each other. Okay, so now we want to treat decimals. A decimal is a fraction written using the decimal point, not format. Sorry, points. Okay, so let's take 3 over 4 for example. 3 over 4 can be written as 0.75. Now you may be wondering, how did we get 0.75 from this number? And it's honestly quite simple. Let's do something like this. We'll have the denominator here and the numerator here. So let me switch colors again. So 4 in 3 is not possible, so we're going to write 0. And since there's nothing we can do, we're going to put a point here. Now we're going to add a 0 to the back of this number, to the back of the 3, okay? So 4 in 30 this time around, we're taking it together. 4 in 30. Remember, the first step we did was 4 in 3, and that was 0. So we add a point next to it, because now we're going to add an extra number, which is what? 0, to the back of this numerator here. So now it becomes 4 in 30, and 4 in 30 is what? Let's actually use a calculator. So 30 divided by 4, and that will give you, it's saying 7.5, but we can actually just do this, because 4 times 7 will give you 28, and that's the closest one to 30. But if you go a step further and say 5 times 7, that will give you 35. So, oh, sorry, 4 times 8 actually. 4 times 8 will give you 32. So 32 is more than 30 and 28 is less than 30. So we're going to use 4 in 30 to be 7. So 4 in 30 is 7. And if we write 28 here, that's basically saying 4 times 7. I'll give it 28. And we subtract it, we're going to have 2. Okay, 2. So we add another 0 at the back again, and 4 in 20 this time around we gave you 5. So that's how we arrived at 0.75. So, okay, that's that about fractions and decimals. Okay, so now let's learn about significant figures. Okay, so next topic now is significant figures. So significant figures are the digits in a number that we consider to be meaningful. You can also actually search up the meaning of significant in the dictionary, and it will actually bring up the meaning. And the meaning of significant is something that carries meaning, something that you consider important. So it's still the same thing as what I just said, which is significant figures are the digits in a number that are meaningful. Now, what are the rules to determining significant figures? One of the rules is that all non-zero digits are significant. Basically, all numbers that are not zeros, that is not zero, is significant. That don't have zeros. Do you understand? Or are not zeros, like 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, they are significant. The second rule is that zeros between digits are significant. For example, okay, let me actually write that out. Zeros between digits are significant. Okay, so you can, if you have something like 200, or let me say 2034, 0 is still considered significant. This 0 is still considered significant because it's between other digits that are not zeros. So 0 here in this 2034 is significant. The third rule is leading zeros are not significant. And the fourth one is trailing zeros are significant. Okay, sorry, significant only if there is a decimal point. So, what does this third rule mean? Leading zeros are not significant. Let's take a look at this number 0.00045. Now, what are the leading zeros here? Which numbers? These. And they are not significant because they are the leading zeros and we don't consider them significant. So, the actual ones that are significant are 4 and 5. Or if you have something like 0.06, the two zeros before the 6 are not significant. Only 6 counts. Now let's take a look at another one. 0.090. Which zeros don't count? These two zeros. But 9 and this 0 at the back, 9 and this 0, these two are significant. But these other two are not considered to be significant. So I hope that one is clear. So we can now move on to trailing zeros as significant if there is a decimal point. Let's take a look at this one, for example, 4.5000. Now there's a point here. This is a decimal point. So which numbers are going to be considered significant? All of them, because there's a decimal point here. So all these other zeros are considered to be significant. Let's also look at 10.0. All of them are also considered to be significant. Now, what about if there is no decimal points? If it's something like 45000, which numbers would be considered significant? Only the 4 and 5. These other three zeros are not going to be considered significant because they do not have a decimal point. And if you go back to our first rule, it says what? All non-zero digits are significant. That means the zero digits just these numbers, 0 digits, they are not significant. So I hope this one is clear, so we can move on to our next topic, which is decimal places. Decimal places, yes. Well, let's actually take a few examples on significant figures. Round 3.54567 to three significant figures. Three significant figures. Now, what are the first three significant figures? 3.45. Those are the first three significant figures. Now, what's the number before the 5, or after the 5 rather? 6. 6 is greater than 5, so we're going to round it up to 1 and add it to the 5 next to it. That is, round this one up to 1 and then add it to this one. So we're going to have 3.46 to be the final answer. Let's try another one. Round 0.009876 to two significant figures. Okay. So what are the first two significant figures? Remember, all these zeros do not count, and we're following the um, third rule. Leading zeros are not significant. So these three zeros here, they are not significant. So our two significant figures are actually 9 and 8. So 9 and 8 are our significant figures. But what's the number after this 8? Which is what? 7. And 7 is greater than 5. So I'm going to round it up and add 1 to this number here. So it's going to be 99. But it's not going to be our final answer. We're going to do 0.0. We're still going to add those other two zeros from before, or three zeros rather, and then add this to, this is the final answer for this question, 0.0099. Okay, so I think that's enough for this video. Come back again for the next video. Thank you.